6, 3, yep. Oh, and 10, that's right. Oh, and guess what? One more thing. Always, and it's always like this for every number. Of course, 1 and 30 itself is going to multiply to get 30. Yeah, so me, I personally like to put these in number order, so I'm just going to do that. Yep. There you go. Yeah. Oh, negative numbers. We're not gonna talk about negative numbers. We're not learning negative numbers in this class. So yeah, 30, I think we got them all. We got all the factors of 30. Okay, let's do another one. Let's do. Let's say, hey, can someone give me 54? Okay, try this, guys. 54. Ooh, who can get all these? Yeah. Okay, everyone got it? Yeah, that's right. Okay, so yeah, we know that 9 times 6 is 54, so that's 9 and 6 are 1. And always, and no matter what number it is, we know that 1 is going to be, because 1 times 54 is going to be 54, so 1, and then the number itself is always going to be one of the factors. And then 54, let's see, 27. Yeah. 54 is an even number, so you know that it's going to be divisible by 2. So we know that one of the factors will be 2. And then 2 times what equals 54? Yeah, 2 times 7 equals 54. 9, 6, 1, 54, 2, 7. Are we missing anything? I think we got. And then, 3 times 18. Good. Thank you, chat people. Yeah, so 3 times 18. Oh. Yep, 3 times 18 makes 54. So we got them all. All the factors of 54. Ooh. Yeah. Good job, people. Excellent. Yeah. So did everyone finish writing all this? I mean, you don't have to write these down, but everyone finished writing all this down? I'll give you a few seconds to write it down, finish up. The rest of you who are still waiting, who's already done writing and still waiting, you can follow this fireball right here. Yeah, fireball. Try to catch it. Can you catch it? Catch the fireball. Oh, some people caught it. You caught it. You caught it. You caught it. Oh. Okay, is everyone done writing this down? I'm gonna go back now. All right, so good job, everyone. So now we're gonna go back. We're gonna go to the book page. Let's see. In fact, yeah, good job on that one, factoring some of these numbers here. So here you go. You get a cookie. Yeah, nice, delicious cookie. Yeah. Okay, so um, let's see. Okay. Okay, prime factorization. Yeah. Okay, so secret code, decode code, and let's. All right, guys. So prime factoring. So I'm gonna read this problem right here, and okay, secret codes are often used to send info over the internet. Many of these codes are based on very large numbers. For some codes, a computer must determine the prime factorization of these numbers to decode the info. The prime factorization of a number is the number written as product of all of its prime factors. Yep. So yeah, prime factorization. What was the prime number again? So, yeah, prime numbers are numbers that you can only get when you do 1 times that number. Yeah. So 2, 3, 7, 11, all are prime numbers. So, and then factoring, we just did factoring. Those are numbers that multiply to get another number. So prime factoring is a number that can be written as a product of all of its prime factors. So what we're going to do is that we're going to take numbers, and then we're going to keep breaking them down. We're going to factor them, break them down into their smaller numbers, their factors, until they become nothing but prime numbers. Yeah, prime number. So secret codes often used to send info. So some codes, computers must determine the prime factorization of these numbers to decode the info. Yeah. Okay, so now we're gonna decode. We're gonna decode some of these computer codes. Okay, so let's start with 180. Yep, this is our first problem. 180. Big number here. Okay, so first, let's look at 180. How should we begin? Using basic fact? Okay. How should Tell me, how should we begin with 180? How do we factor them? What numbers do we know multiply to get you 180? Or you can think of it like this: 80 can be 180 can be divided by what? What can you divide 180 by? Because remember, multiplying and dividing are opposites of each other. Okay, so yeah, a lot of you said 10 and others said 18. Okay, so yeah, good job, everyone. So you see 180, it has a 0 as the last digit. So now you have anything that has a 0, last digit 0, like that, we know it's got to be a tens number. So yeah, 180 is a tens number. I mean, it's a hundreds number, but it's also a tens. There's 18 tens right here. And yep, so if it's a tens number, it's divisible by 10. So here it is, how they have it written. And so 10 times what equals 180? Yeah, 18 times 10 equals 180. You can even see it right there. Yeah, see the 18 right there? 18 times 10 equals 180. Yeah, and then now what? So base. So now that we got 10 and 18, okay. Now we have prime factoring means we have to keep factoring them until they become prime numbers. So is 10 a prime number? No. Is 18 a prime number? No. You can do 9 times 2 to get 18. You can do 6 times 3 to get 18. So 10 can be factored. How can we break 10 down even more? Yeah, 2 times 5 is 10, so we'll do that. 2 and 5. And then, so is 2 a prime number? Yeah. And then is 5 a prime number? Yeah, because there's only one way you can get 2 or 5. Only multiply by 1. Okay, so 18. What can we break 18 down into? That's right, 3. Yep. So 6 and 3, and then 6 and 3, and then 6 can be broken down into 2 and 3. And yeah, we know 2 is a prime number. Is 3 a prime number? It is. Yep. You can only get it by doing 3 times 1. So we got all the prime numbers here. This is called the tree method. Yeah. I think it's the easiest way to break numbers down. So, yep, when you start doing this, do the tree method. So the prime factorization of 180. Okay, when you are done, you have all the little separate numbers right here. This is how you should put your answer. I want everyone to have it written like this. Okay, so there's 1, 2, there's another 2, and then there's a 3, then another 3, and then 5 right here. Okay, we got it. 2 times 2 times 3 times 3 times 5. Yeah. So when you're done, you should have your answer written down like this. Because 2 times 2 is 4, times 3 is 12, times 3 is 36, times 5 will make it 180. Yeah, how many people got that? And yeah, I know some people factored it differently. So here's another way of factoring it. Yeah, I'm looking at the chat, and I know some of you did it differently. Okay, so if you didn't do the 10, like 10 and 18, well, some of you, like, you looked at 180 and you know that 180 is an even number. Yeah, so if it's an even number, you know that it's divisible by 2. So 2 times what equals 180? Yeah. Here's a little trick. Yeah. I know we can't really think in our heads 2 times what equals 180, but if you ignore the 0, and think of it as 2 times what equals 18. Yeah, 2 times 9 equals 18, so I know that the answer is going to have 9, and then I can just put that 0 back in, and there you go. 2 times 90 equals 180. And then 2 is already a prime number, so we're good with that. And then 90 can be divided as, okay, well, let's see, well, 9. We know 9 times 10 is 90, so 9 and 10. And then factor more, 3. 9 can be broken down to 3 times 3. And those are prime numbers, so those are done too. And then 10 can be broken down to 5 and 2. And those are prime numbers. So we got it. 2 times 2 times 3 times 3 times 5. Okay, yeah, I'll give you a few more seconds to write this down. If you want to write down the second one. Okay, everyone good? All right, so I'm gonna go down now. Okay, kiddies, time for you to show time to show your prime factoring skills. Yeah. Okay, let's try to do number 4 and number 5. No, you don't need to do number 3. Find the prime factorization. Okay, I'll give you 2 minutes. 2 minutes enough? Yeah.
What's the matter?
Gordon said that I had to get the question he was doing faster, and that's not true.
Gordon.
Okay, so okay. How is everyone? Okay. Oh, and yeah, teams. Teams, my 4th and 5th and 6th grade teams. If you got both answers, and you want to answer for your team, you can type it on the chat right now. I don't know what grade each of you are in, but put your grade next to your answer, or if you already have your grade next to your name, then you're all set. But yeah, yep. If you want to answer for your team, then put it and put your grade next to it, so I know which team that is. Good job. Yeah, I can see the answers. Yep, 5th graders got it. 6th grade team got it. 4th grade team got it. Yep, I see it all. Good job. Okay. Okay, so all right, so 12 can be broken down to what? Give me 2 numbers. Yep, 4 and 3. Yep, okay, and then is 4 a prime number? Okay, yeah, nope. And so we break it down more. 2 times 2 makes 4. Yeah. Is 2 a prime number? It is. So 2, 2, and then 3. 3 is a prime number too. So we got it. 2 times 2 times 3. That gives you 12. Yeah. Awesome. Yep, and every team got this one right. So good job, teams. You all get a point for that. Okay, number 5, 65. Someone give me some give me what should be my first 2 numbers. Okay. Yeah, so you know that 65 5 means it's a 5's number, so you know that 5 is definitely one of the factors. So it's divisible. It can be divided by 5. And 5 times what equals 65? 65 divided by 5 is what? It is 13. Yep, and both of these are already prime numbers too. Yeah. Yeah. Yeah, good job. Okay, next, okay, so we're gonna, hold on. Yeah, good job, teams. Yep, 4th, 5th, and 6th graders got that last question too, so that's another point for you. Good job, teams. Here's your next read. Confetti cake. Slice of cake there. Okay, eat it up. Everyone done? Okay, good. Let's go on to the next math problem. Oh wait, okay. Let's see. I'm gonna. Okay, greatest common factor is next. So, okay, all right. Greatest common factor. All right, who wants to do some more factoring? Yeah. Yeah. Oh, some people are still eating the cake, huh? I think some people took a slice and ran. Ran. Mine. Okay, so we learned about factoring numbers, breaking them down into smaller factors, the numbers that multiply together to get that number. So the next thing we're going to learn is greatest common factor. These are a type of numbers that they're the type of numbers that show a relationship with other numbers. Okay, so I'm gonna show you right here. Okay, greatest common factor. Okay, all right. So, okay. Oh, someone said they took the extras. Someone took some extra cake. Hey, the cake is for everyone. You can't take other. Amelia fed it to the dog. Oh, okay. See. And some people ate it in one bite. All right. So, greatest common factor. They are factors that two or more numbers share that are alike. And how are they alike? Well, greatest common factors. Okay, we already know what factor is. We know what this word means. So what does greatest mean? What is great? No, don't talk with your mouth full. Some people are still eating the cake. Class time. Biggest. It means biggest, largest, the highest number. It means the most. Yeah. And then what is common? What does common mean? Common. Yeah. Common means like alike, the same, something relatable, related. Like, for example, all of you have something in common. You are all students and you are all studying math together in this class. So everyone here has something in common. We are all learning math. And so, yep, greatest and then common. And now, so greatest common factor means a number, the highest number that two numbers have in common as a factor. A factor that the highest factor that two numbers have in common. So let's look at 12 and 24. Okay. I thought some people were still eating. Okay. Okay, so what are the factors of 12 and 4? Yeah, just factors. We're not prime factoring. We're just giving me the list of numbers. Oh, in fact, here, let me do this. I think I'd rather do it like this. Yeah, like this. 12 and 24. Yeah. Okay, so yes, 1. I know always know that 1 and 12 are definitely numbers. 3 times 4 is 12. And then 2 times 6 is 12. Did we get them all? Yeah, just about. And again, I just I like to have them in number order. So from smallest to largest. How about 24? 1, 2. I know that 1 times 24 is 24. 2 times. Now here's a little trick. When you guys are making a list of all the factors for a number, just start with 1 and then just go up. So 1 times what equals 24? Oh yeah, 1 times 24 equals 24. 2 times what equals 24? 2 times 12 is 24. 3 times something equals 24? Yes, 3 times 4 equals, no, actually 3 times 8 equals 24. And then 5, no, nothing times 5 equals 24. 6? Yeah, 6 times 6 equals 24. 7, 8. Okay, I can stop at 7 because right now I already have the numbers 8 and above. So once you already get to these numbers right here, that's it for factors. Okay, good. Everyone, good job on the chat. You listed out all your numbers already. Okay, so now common factors. Can someone tell me what are the common factors in this? Yeah, 1. I'll circle them. You can circle them like this. 2. They both have 2 as a common factor. 3. Yep, they both have 3. Only 12 has 4, so we're gonna skip 4. But they do have 6. Yep, they have 6, and then they have 12, and then that's it. Okay, so what is now all together? What is the greatest common factor now? Yeah, the greatest common factor has to be the greatest out of all the common factors. So the highest out of all the numbers I just circled. So the 12 is the highest, right? So 12 is the greatest common factor here. Yeah. Everyone doing good? Anyone sick from all the cake and cookies? Yeah. I told you shouldn't have 2 slices. But thank you for feeding the dog. Yeah, everyone. Yeah, I'll leave the chat on public so you guys can all see each other's silly comments. How was the cake? Delicious? What was in the cake? Yeah. Okay, so anyway, I'm gonna bring us over to the math page now. Okay, greatest common factor. Okay, so anyway, yep, a greatest common factor. Common factor is a number that is a factor of 2 or more numbers. So let's say 16 and 20. Yeah, what are the factors of 16 and 20? Okay. Uh-oh. I think the chat is going a little out of control. Okay, I closed down the chat now, so no one can see each other anymore. Everyone paying attention? Pay attention right here. So what are the factors of 16 and 20? Yes, they are 1, 2, 4, 8, and 16. Yeah, and then what are the factors of 20? Yeah, 20. The factors would be 1 and 20. Yep. And then 2 and 10. Yeah, guys, do it like this. Just start from the number 1 and work your way and then just work your way until you hit the middle point. See, look, I know, starting with 1, I know that 1 times 20 makes 20. And then going up to 2, I know that 2 times 10 makes 20. And then going up 3, nothing times 3 is 20. So we're going to go to 4. 4 times 5 is 20. And then, look at that. I already hit the midpoint. So, yeah, I was coming in this way from 20 going down. And then coming in that way, 1 going up. And I already hit my midpoint. So that is when I know I can stop factoring. Okay, so what are the common factors? Yep, 1, 2, and then 4. So what is the greatest common factor? Yep, the greatest common factor of 16 and 20 is 4. 4. Yeah, so good, right? Okay, so all right, so greatest common factor. Greatest common factor is the greatest factor of 2 or more numbers that are common. Yeah, I know. I'm trying to draw with my mouse. Sometimes it's not very. It's a little messy. Okay, all right, my Fortnite champions. Okay, so what are greatest common factors for? What do we do with them? I mean, why do we need to know? Why do we need to know when 2 numbers share the same factor? Okay, so unlock the problem. Ready? I'm gonna begin reading. Jim is cutting 2 strips of wood to make a picture frame. The wood strips measure 12 inches and 18 inches. He wants to cut the strips into equal lengths and that are as long as possible. So what length should he cut the wood? Okay, guys, so look at this. Jim, he cuts wood. So he has 2 wood strips right now. He has one that's 12 inches and the other is 18. And now, okay, the two different lengths, one is 12, the other is 18, but he wants to cut them into equal strips. He wants to cut them so that way he can have the same number of equal strips and not have any left over. Because you can see like this is only 12, but this is like 18. So like, how do we know? Okay, what lengths should we cut the wood into so that way we can have equal number of pieces and not have any left over? Okay, please don't spam the chat. Okay, so now this we use the greatest common factor. Greatest common factor. So we're going to find the GCF of 12 and 18. And this is how we are going to find a common number that will be able to divide both of these numbers and both be equal and be able to provide equal lengths without anything left over. Like a remainder. When you divide and you have a remainder, yeah, that's what we don't want. So what's the greatest common factor of 12 and 18? Okay, list your factors of 12 and 18. Go. List your factors. What are the factors of 12 and 18? Yeah, 12, 1. 1 times 12 is 12, and then 2 times what? Yeah, 2 times 6 is 12, so 6 and 2. And then what are the other 2? Yep, 3 and 4. 3 times 4 makes 12. Yeah, we got it. And now 18. What are the factors of 18? 1 and 18. And then 2 and then 9. 2 times 9 is 18. You see how this way is going up, but this way is going down? To know if you are done factoring, you just keep going until you hit the middle. So I'm going to go next. I'm going to go to 3. Does 3 times something equals 18? Yeah, 3 times 6 equals 18. Good. How about 4? No, 4 times nothing times 4 equals 18. And not 5 either. 18 is not a 5's number. So we got it. Yep. And we met in the middle, 3 and 6. So we're done factoring. So 2, 3, 6, 9, 18. Okay, so what are the common factors? Give me the list of all the common factors. Yep, 1, and then 2, and 3, and then 6. Is that it? Yep, and that's all the common factors for both numbers. So what is the greatest common of 12 and 18? It is 6. Yeah. Good job. Good job, my secret Roblox fans. Yeah, the number is 6. Yeah, everyone got it really well. Yeah. Okay, I'll give you a few seconds to write this up, and then we're gonna work on some problems independently as teams. Okay, so actually, and also this is to tell you that Jim is gonna have to cut the blocks in 6 inches to get an equal number of inches. In fact, yeah, we can see right now when you cut it into 6, yep, you get equal amounts of each without anything left over. Everyone done? Yep. Yeah, we have 9 minutes left. We're gonna work on some independent problems together. Yeah. Okay. All right, everyone. And no, we're not gonna do this. We're not gonna let the distributive property. Okay. My obsessive Minecraft players. Now I'm gonna have you do. This is gonna be tough. Yeah. I'm gonna have you do number 10 and number 12. No, you don't need to do number 11 or 13. If you want to, yeah, you could. If you're done early and you're just waiting around, you can try the other one. But nope, everyone really needs to do is 10 and 12. Find the greatest common factor. Okay, teams, go. Yeah, which team is gonna get both of the answers? Yeah. And no spamming, no flooding or spamming the chat. Now, some of you are new. If you spam or flood the chat or put things that are not nice or appropriate in the chat, then you will be removed from this class. So, okay. Give you a minute and a half left. Okay, I'm turning off the chat because obviously we can't use the chat appropriately. Okay, so no one can see anyone's message anymore. Okay, 30 seconds left. And someone from the 4th grade said the 5th graders were spamming. We're not gonna point fingers at certain grades. No, we're all one big happy family, a family of teams, but not happy. Yeah, we're all nice to each other. 4th, 5th, and 6th graders. Okay, so anyway, 8 and 25. So let's see, 8. Oh yeah, if you got the answers and you want to answer for your team, put it on the chat with your grade level now. Okay, so 8. What are the factors? 1, 2, 4, and then 8. Anyone else? Okay. So and then 25 is 1, 5, then 25. This was a tricky one. Okay, everyone. So I know this one is really weird because 8 and 25 are completely different numbers. They're very different. One is an even, the other is an odd, and it seems like they don't have any factors, any common factors, but they still do. For number 10, the answer is 1. Yep, the common factor is 1. Okay, and then next, 56 and 64. I know this one's gonna take forever to. Let's see. What? I'm gonna type. I'm gonna type the inf. Okay, so what are the factors of 56? 1, 56, 2, 28, 9 and 6. What else? 3, maybe. Oh, 14 times 14 and 4. Okay, so I think that's it. I know this is really small. Okay, and then yeah. Okay, 1 and 6. Okay, 64. 1, 64. And then 2, 32. These are very big numbers here. 16 and 16 times something equals 60. 16 and 4. And what else? 8 and 8. 8 times 8 is 64. Okay, so 1, 64, 2, 32. Okay, okay, what is the greatest common factor? Okay, so 1, and then 2, and then they both have 4. Then they both have, oh yeah, and they, actually 8. Oh yeah, I forgot 8 and 7 back here. Okay guys, 8 and 7. Yeah, I forgot about that. 8 times 7 equals 56. So they both have 8 as a common factor too. So the answer is 1, 2, 4, 8. It is 8. The answer is 8. Just one here. Yeah. Everyone okay with that? No one had a problem with that? Yeah. I mean, yeah, actually, that's not supposed to be 2 8s here. I'm just, because 8 times 8 is 64, that's why I put 2. But no, there's really 1 8. Okay, so yep, there it is. There are the answers. Okay. Yeah, everyone really excited. Good job, people. Yeah, everyone did a great job today. Yeah, so now if you participate on the chat, great job. You get a great job star. Ooh, sparkly star. Yeah. Yep. Okay. So now the teams did a great job today. So yeah, all the teams can pick where to take Braxton out for a walk today. Yeah, there you go. Braxton. That's his name. Yeah. Okay, so where should we take Braxton out for a walk? The park, the swings and the slide, the school playground. So there's the school, there's a tree. Or should we take him to the bike path? Yeah, a nice cool bike path. So where should we bring him? Put it on the chat. Yeah, park, bike path, park, bike path, park, bike path, park, bike path. Okay, I think more people said park, so we are gonna take them to the park. Yeah, there you go. Ooh, yeah, yeah. Who wants to push them on the swings? Yeah, if you want to push them on the swings, yes, say so. Yeah, a lot of people do. Okay, who wants to push him down the slide? He's gonna go up the slide. Yeah. Okay. Awesome. Yeah. Woo. Okay, everyone. So tomorrow we're gonna learn least common multiple, and then possibly get into fractions tomorrow. Yep. And look over your notes today, and if you have questions, you can bring them tomorrow before class, right before class. I could possibly answer them. All right, guys, have a great night. Yeah, sleep well. And who who can who wants to volunteer to bring Braxton back to the school? Yeah. Yeah, who wants to bring Braxton back to school? Yeah, volunteers. Yeah, yeah. Braxton needs to get back to school. Yeah, everyone. Yep, everyone's really excited. Everyone wants to bring him back. Yeah. Okay. Yep. If you said so, if you said it on the chat, then yep, you can bring him back. Okay, everyone. Bye. Bye. Have a good night. Bye.